Hello guys. uh, I'm fulfilling another subject request, which was electro electronics, industrial electronics and 5. Yes, industrial electronics and 5. So I'm fulfilling that request. So mna guys, what I do, I specialize more with calculations, yabo. When I teach, I do more calculations than the theory, more especially when it comes to from N4 to N6 level. What they expect from you is calculations. They do ask theory there and there, and but theory igcwele from N1 to N3. Yabo. Here we are just calculating. If anyone has a question with theory, they are welcome to also ask about, okay, usofunda le paragraph about, let's say about a resonant, and I understand it until then I will go through that paragraph and read and explain. But now I got a question up 80 from the previous question papers. This question: a network consists of 3 branches. So we have 3 branches in parallel. Okay. Sorry. But branch A is a 10 ohm resistor. Okay. Branch B is a coil with a resistance of 4 ohms. Okay. So we have a coil. Remember guys, a coil kaloku, i-inductor, i-coil, it's a wire. Yabo. A coil in a resistance, even though in a inductance nje. A coil in a resistance because it's a wire. In fact, every material in life, every matter in existence, has a resistance. My body has resistance. Umoya une resistance. Umoya is made up of compounds that are in a gaseous state. Yabo, they have resistance. Yabo, for us sikwazi uconductor umbane emoyeni, if we can apply a very high voltage, singenza umbane aflow through the air, and that because air is matter. Yabo. Okay, so continuing, branch B is a coil with a resistance of 4 ohms, okay, and an inductance of 0.02 Henry. Branch C is a resistor in series with a 200 microfarad capacitor. Okay. But the combination is connected to a 100 volt 50 hertz supply. So the first thing, let us draw a circuit quickly. Let us draw a circuit here to quickly. Okay. So ngizoqala branch A, which is a 10 ohm resistor. Yeah. That is branch A. Then branch B. What do we have in branch B? We said we have a coil. Nah? Okay. That's a coil here too. When you are representing the resistance of a coil, you always connect it in series, guys, please. When you are representing, xa urepresenta, mandiyibeke nangesintu, xa urepresenta i-resistance ye-coil, you connect her in series nalo coil, because resistance of that coil will always appear to be in series, never in parallel. Yabo, please. So let us connect it in series. So le resistance represents a resistance coil, which is 4 ohms, and in an inductance of 0.02 Henry. Okay, that is branch B. Okay, then ke ngosiphinde sibe nantoni, sibe ne resistor that is in series with intoni, a capacitor. Okay, 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 okay. By the way, what we are doing we are doing AC circuit calculations. Okay, so it's 8 ohms. Capacitor is 200 microfarads. Okay, then we have a source engu AC na, which is 100 volts at a frequency of 150 hertz. Okay, this is branch C na, but we must calculate the current through each branch. So we must calculate the current through this branch IA, the current through this branch IB, the current through this branch IC. Right off the bat, let us write the formula. Right off the bat, what do we know about a parallel circuit? We know that in a parallel circuit, let's call this IT. We know that in a parallel circuit, the voltage across each branch is the same as the supply voltage. In other words, if voltage across this branch go 100 volts, 100 volts, 100 volts. Okay, and we're gonna use Ohm's law. I is equals to V over, let's say Z in this case, since it's still an AC circuit. Let us say impedance. Okay, so if ndifuna ubala I through the first through branch A, we're gonna say VT with 200 volts over ZA. Ibe current through the second branch, which is VT ZB. The C branch, VT over ZC. Okay, so meaning, guys, okay, upper we can calculate, we have a voltage, a value of voltage, and a value of voltage. And guys, please, if voltage, if supply voltage, you always take it as your reference. In other words, if I'm gonna represent a voltage in polar, it's gonna be VT 0 degrees. We always take it as our reference phasor. Yabo, a voltage. Yabo, because a voltage in a parallel circuit is the same. Nah? In the that is out of phase. In one, the current. Okay. Let us first find OZA. OZA is easy to find. OZA is equals to just 10 ohms. Okay, as we put it in OZA is 10 ohms, nah? As we would put it in what, in polar, you can say 10 0 degrees. And it okay, let's put it in polar. Because why am I putting in polar? Because it is a divider up. Okay, then let us calculate ubani uzb. uzb kubani ngu-4, okay, plus j x l. Okay, so what I have to do first, I have to calculate to xl. Yabo guys, we as electrician, we justify our existence by using j instead of I. Yabo, but j no I is the same thing. So kanithetha ngo-j kwi-calculator yakho ngu-I. Okay, so uzb is your, sorry, the calculator xl, and xl is 2 pi fl. Okay, and which is 2 pi, frequency ngubani ngu-50, then sorry, inductance basinikile ngo-0.02, so let us get to xl. Okay, let's just punch on our calculator. 2 pi, 2 pi, yes, 50, okay, 0.02, okay, 0.02. Then that is gonna be 6.283 ohms. Okay, that is XL. Now we can actually determine OZB. OZB is equals to 4 plus J 6.283. Then let us put it in polar because it's a divider. To do that, you use your calculator most. 4 plus J, so 6.283. Okay, by in polar we get 7.448. then i-angle yethu, sorry, i-angle yethu ibe ngu 1.004 degrees. Fine, then we have calculated ubani uzb sambeka in polar. Let us find let us find uzc. uzc is given by a resistance yethu ngubani ngu-8. ngu-8 minus jxc. So we have to calculate xc. xc is given by 1/2 pi, 1/2 pi fc, which is equals to 1/2 pi, frequency ngu-50, then uc kubani ku-200 micro times 10 to the power minus 6. Okay, therefore xc kubani xc, let me punch it first. Okay, so xc it's 1/2 pi, open bracket, 50, 200 times 10 to the power negative 6. Okay, which is 15.9 915 ohms. Okay, now we can place ke ngoku uZC. uZC is basically ke ngoku 8 minus J 15,915. And now let us punch that. 8 minus 15,915. Okay. So bano 17,813 negative 1,105 and in polar. Okay, now that we have found impedances zethu now, we can find IA. IA, its termos is VT over ZA. So it's gonna be IA is equals to 100. Detail, you always take a voltage source as a reference. Hence, I'm putting 0 degrees over 0 degrees. Then OZA is 10 over 0 degrees. So IA is equals to IA is basically equals to 10, then angle yethu mani ku 0 degrees amps, and then ke ngomele sifune bani so therefore IA, then sifune bani IB. IB is equals to VT over ZB. VT kubani ku 100 and angle go 0, then sibe no 7,448 and i-angle mani ku 1,04. Okay, so therefore IB will be IB would be 100 over 7,448. That is gonna be 13,426. The angle negative 1,04 amps. Guys, that negative makes a lot of sense. It makes a lot of sense because inductor, that negative means the current is lagging the voltage, and that's the property of a inductive circuit. Immediately if we positive kule branch which is in inductance, boyazi ba ikhona into ikhona kushaya amanzi, yabo, because kaloku if you have an inductor in a circuit and an inductor that is more, or a circuit that is inductive, you have a lagging phase angle, hence you have minus. Current is lagging the supply voltage. So bona draw a phasor diagram. Then we have to get IC. IC is equals to VT over ZC. So VT ngubani 100 angle ku 0, then ibe no uzt ngu-17, uzc ngu-17,813. Okay, i-angle being negative 1,1105. Okay, i-angle being okay, is that 5? Let me just confirm bang 5 lower writing yam minus 10 comma. Okay, oh yeah, 5. Okay, no, it's fine. That means ke ngoku IC is equals to 100 over 17,813, which is equals to 5,614. I-angle, yabo i-angle zoba positive. It makes sense because a current is leading the supply voltage. Okay, you have therefore calculated all the currents. The next question says, draw a phasor diagram showing the relative position of the various current. Okay, let me first draw a voltage source. Since the city voltage source is the reference, yabo siyibeka phi kwi-horizontal line, yabo i-reference yethu siyibeka sona. Okay, basiqale sijonge ubani u-IA. U-IA siyabona ngu-10, angle ngu-0. That means u-IA is in phase with the supply voltage. So izoba lapha iphase yakhe. Okay, so ngu-IA lo. Okay, then u-IB, we see that u-IB it's lagging the supply voltage. Guys, into kayino-negative, it means that we are going clockwise, negative. Then positive, we go anti-clockwise. So apha i-angle kubani, sorry, i-angle ubani ku-negative. So let's say u-negative IB na. So let's say nanko negative bani, negative 1,004. Yabo, I'm going clockwise because it's negative. Then when it's positive, for example, or IC, yabo, it's okay. Okay. Okay, which is angle 1,105 degrees. Okay. Guys, please continue subscribing to my channel, and if you have any subject request to Ucho. So this is it for this section, industrial, which is AC circuits. Thank you.